Honors Algebra, Mr. Lawrence here with your flipped lesson for the weekend. Yes, OAA testing is over, but we need to keep plugging on. We've got Honors Algebra going on. We've got a final coming up. I know DC and a lot of other distractions. We've got to stay the course. You know, can't run out of gas yet. After the final's over, we'll relax. We'll take it easy. All right. Have a couple days just kind of chilling. But until then, we're going to keep working hard. All right. You guys can do it. All right. By the way, from what I saw, the effort that you guys gave on the math part of the OAA, I was very pleased with. The kids in my homeroom worked really hard, and I'm assuming that you guys did as well too. Gave it your best effort. I saw people writing formulas on their formula sheet that weren't there. Saw people copying Venn diagrams down to help them get things right. Very proud of the effort. All right, so let's talk about adding these rational expressions. All right, remember that to add two fractions, we need an LCD. The whole trick here is getting the correct LCD. We can get any old common denominator, but man, the problems can get really ugly really quick if we don't get the least common denominator. All right, the first thing I'm going to do is I'm going to look at these two fractions. I'm going to look at the denominator on the left, 3 over x minus 1. I know that x minus 1 has to be a part of my LCD somehow. So I'm going to write x minus 1 as a quantity over there. That has to be part of my LCD, right? You can't just write x over there because x doesn't account for an x minus 1 or an x plus 1, right? Then I notice that I need an x plus 1 in my denominator, my LCD. I ask myself, are all parts of all denominators accounted for? And in this case, they are. So I need both my denominators to look like this. So I'm going to go to each fraction, and I'm going to multiply the denominator by the part of the LCD that it's missing. In the case on the left, it's a quantity of x plus 1. But if I multiply downstairs, I have to also multiply upstairs. Over on the right, the quantity that's missing is an x minus 1. And if I multiply downstairs, I have to multiply upstairs because I'm only multiplying by a very special form of 1. I'm not changing the fraction or the rational expression. I'm just changing the way it looks. All right, so now I am going to distribute this 3 to the x plus 1. So the fraction on the left is going to turn into 3x plus 3 over the quantity of x plus 1, x minus 1. Now, some of you are going to want to write x squared minus 1, and that's perfectly fine. You can do that. All right, on the right, I'm going to distribute the 2, and I'm going to get a 2x minus 2, and that'll be over x plus 1 times the quantity x minus 1. My denominator is the same. I can go ahead and combine like terms in my numerator. I've got 3x plus 2x, which is 5x. I've got a positive 3 and a negative 2, which is a positive 1. And I have x plus 1, x minus 1. And that is an acceptable answer. Again, you could have foiled down in the denominator. I like it unfoiled in the factored form. That way I can tell if it needs to be simplified any further. And in this case, it does not. So there we go. All right, let's try this one. Again, we're going to identify the LCD first. And you know, right off the bat, I see I need an x. So I'm going to put an x in my LCD. That x does not take care of this x, though, because that's not an x. That's an x plus 2. So I need an x plus 2 in my LCD. Is everything in my denominators accounted for? Yep. So I'm ready to get the common denominator in my two fractions. The first fraction, I'm going to need to multiply by an x, and I'll get x squared over x times the quantity of x plus 2. All right. The second one, I'm going to need to multiply by the quantity of x plus 2 in the denominator and by the quantity of x plus 2 in the numerator. Now I have to be careful here. I'm going to bring this negative down, the minus. I'm going to distribute the 3 and get 3x plus 6 over x times the quantity of x plus 2. Some of you are going to get this wrong here because what you're not going to realize is this negative belongs to both 3 and to the 6. In fact, I'm actually distributing it. What you could have done is on this step, you could have distributed negative 3 because my final answer is going to be x squared minus 3x plus 6 over x times the quantity of x plus 2. Now I should check this numerator. Oops, I made my own mistake. I just warned you guys that you were going to get it wrong and I did it. Oh my goodness, Mr. Lawrence. All right, so it should be minus 6. There we go in the numerator. Good thing I caught that, or otherwise Andrew and Brendan would have told me all about it on Monday. Oh man, thank goodness. All right, now I should check this numerator and see if it can be factored. Can I subtract 2 factors of 6 and get negative 3? No, I cannot. So I know I am done, right? Factors of 6 are 1 and 6. 6 minus 1 isn't 3 or negative 3. 2 and 3, I can't subtract those 2 and get a negative 3. So I know I'm good. All right. If it had been able to factor, I'd factor it, and then maybe something would have canceled out. All right. Now I'm going to get my LCD, but I'm going to notice something here. See, I'm going to put together all my learning I've done. I'm going to notice that this can be factored. This is the same as x times the quantity of x minus 1. Okay. Why is that important? Well, my LCD is going to need an x, right? And my LCD is going to need an x minus 1. But it also accounts for this one. When I write it over here on the LCD side, it can account for itself in every denominator one time for every time I write it. So I wrote the quantity of x minus 1. It counts in the first fraction denominator and it counts in the second fraction denominator. Okay, it's kind of like when we did a problem like this, 1/3 plus 1/6. I know the LCD is 6, right? If I wanted to, I could break this 6 up into 2 times 3 and then say my LCD is 2 times 3. See, it's the same thing. I'm not going to multiply this denominator by anything because I already have a 6. This one would get multiplied by 2, right? And then I would go ahead and do it. It's the same thing. I'm using a simple problem to explain one that looks more complex. It really isn't more complex. It just looks strange. All right, so my LCD is x times the quantity of x minus 1. Well, look at this. This first fraction already has it, so I'm not going to do anything to it. I'm going to get 5x over x times the quantity of x minus 1. All right. The second fraction, however, the denominator is missing an x. So I'll multiply by x over x, and I'll get plus 3x over x times the quantity of x minus 1. And then combine my like terms, and I'll have an 8x over x times the quantity of x minus 1. Ooh, you see these x's? These x's can cancel out. Yeah. So a better answer will be 8 over x minus 1. All right, now I'm going to pause and go back to each problem because you know what? I did forget to do something on each problem. I'll bet some of you can tell me I forgot to do my restrictions. I've got to say, where's my final answer? My circled answer for number 1 is there in red. But x is not allowed to equal plus or minus 1. Because if I make x negative 1, this quantity turns to 0, and then I have a 0 for a denominator. If I make x positive 1, this quantity turns to 0. When I multiply by the other quantity, I get 0. I can't have 0 in the denominator. So it is very important to include your restrictions. I know I forgot them. I apologize. All right. Let's see. The black one has my answer here. And I know that x cannot be 0 or negative 2. Right? Whatever makes those quantities 0. All right, here on the red one. This is my answer, except I have to say x cannot equal 1, but I also have to say it can't be 0. I have to include that x before they canceled out, because over here in this problem, if x is 0, then my denominator turns to 0. Okay? Now somebody smart like James is probably wondering, hey, could I have done this? Sure, you could have. You could have canceled those x's out and just added, but you still have to include 0 in the restrictions. Okay? All right, one more example, and then we'll get some practice on this Monday during class. All right, I'm going to move this work on down. So I have a little bit of room to work. I'm going to find my LCD. But I'm going to notice, hey, x squared minus 4, that's factorable. That turns into quantity of x plus 2 times quantity x minus 2. Now finding my LCD just became simpler. My LCD is going to need an x plus 2 quantity in it. That'll take care of that guy, and it'll take care of that guy. Remember, one time in every denominator for every time I write it down. The only thing not accounted for is the x minus 2. Takes care of that guy. This first fraction has the least common denominator. I'm just going to write it down. Bring them on down. Okay. The second one is missing an x minus 2. I'll multiply in the numerator and the denominator by x minus 2. I'll distribute the 3. I'm not distributing a negative 3 because I'm adding, right? So I'm going to do 3x minus 6 over x plus 2 times the quantity of x minus 2. All right. So 3x is my numerator, plus 1 is also in my numerator. Denominator is x plus 2 times the quantity of x minus 2. X cannot equal plus or minus 2. Should be getting pretty simple. Should be getting pretty simple. All right, that's how we add or subtract rational expressions. Pretty quick video for you, but we'll get some practice on Monday, and hopefully you'll be good to go. All right, Mr. Lawrence signing off. Have a good weekend, everybody. Bye-bye.